The PHP scripting language offers powerful and versatile methods for creating applications. And welcome to PHP Advanced Topics. In this course, we'll look at the PHP scripting language and learn advanced techniques and practices to build better applications. First, we'll explore new ways to compose PHP through the use of namespaces, interfaces, traits, and other advanced object-oriented techniques to craft more flexible software. Next, we'll look at advanced libraries to solve a variety of common problems. Finally, we'll learn how to use PHP exceptions to prevent our applications from crashing. Now let's dive in. To follow along with this course, you should have both a basic working knowledge of PHP and a recent version of PHP, at least PHP 5.6 or greater, installed on your computer and accessible from the command line. We'll use a terminal application to run some PHP files that we'll create together to explore some of the different concepts I'll explain. If you feel like this material is too advanced, you should look at the PHP with MySQL Essential Training course and the PHP with MySQL Beyond the Basics. If you have access to the exercise files for this course, you can follow along with the same ones I'll be working with on screen. The exercise files are organized into folders, organized by chapter and movie number. Inside each folder is our collection of code we are creating throughout this course, as well as any additional files or snippets needed for that specific video. You can also follow along by creating your own files if you wish. If you don't have access to the exercise files, you can follow along just by watching. Let's start our discussion of some advanced techniques in PHP with namespaces. Have you ever had the problem of needing to name a class the same name as some other class somewhere else in your project, or the same name as some class in a library that you have in part of your project? This is a pretty common problem. You have some library that has a log class, but you also want to write your own log class. PHP namespaces are the solution to this problem. Namespaces give us the ability to tell our code, okay, you can be named log, but only along this particular path. And you can also have the name log, but it's along this other particular different path, such as app, util, log.php. And you can also have the name log class available at vendor, framework, log, log.php. And again, a third log class available at vendor, package, util, log.php. In essence, we get to tell our code, rather than use the first version of the log class you find, use this version along this particular namespace. But more than that, it's more than just separating code between both libraries and packages you are importing. It can even be within your project itself. The namespace is just a way of us telling PHP, find this class here. So we can do this at any point. Using our examples of this app util log.php class, we can tell it to find it at app util log. And again, we can tell PHP to find our particular framework log file at framework log. And again, a package can provide its own log class along a different namespace path. Let's explore the benefits of namespacing. What specifically do we get out of it? One of the goals with using PHP namespaces is making it easier for you to import packages and libraries. If you use PHP before namespaces or never bothered with namespaces before, you may be used to seeing classes named myAwesomeUploaderLog and myAwesomeTable. These weird and not very useful names are trying to solve the problem namespaces deals with. Lots of people want to name classes table and log and other common names, but you can't have two classes named the same thing prior to PHP namespaces. However, namespaces aren't just for the names of the classes. Namespaces also allow you to have multiple functions, titled for instance get, or even provide your own version of a core PHP method such as array map. Namespaces give us the ability to create multiple methods and projects that can use the same name without worrying about conflicts or collisions. This feature, however, is only present in PHP 5.6 or above. Namespaces, in addition to allowing you to import classes from other parts of your project, also permit the ability to alias a class. This allows you to import two classes that have the same name along different namespaces as two different names. For instance, we can import two collection classes, but alias one as collection faker that is provided to us from the Faker library, and import collection from the CSV collection class. One of the other many benefits from using namespaces is we gain access to the whole world of open source software. It now is much easier for us to include and drop into our projects as needed. Composer is a PHP package manager that lets us do just that. We can import and auto-load packages and classes from hundreds of open source libraries and frameworks, and all of them are equally accessible and useful in our core application's code. Autoloading, you say? What's that? Autoloading gives us the ability to write one line in code and use that package regardless of the file path to that code. As an example, remember using require and include? Wasn't that awful? Having to go, okay, this is one level deep, so I need to do require ... /somefile.php, but this other one is 2 levels deep and a folder away, so I need to do require ... /lib / some other file.php. That was awful. Autoloading replaces all of that work and instead figures out how to find the exact path to the class without us having to do any of this crazy work. All you have to do with autoloading is say, I want to use this class at this namespace path, and boom, you get to use that class right away. So let's learn how to use PHP namespaces in the next video. So let's work with some code in a namespace. To begin, we will want to have a project. Let's create a new directory somewhere in your file system. I'm going to do this in my PHP Advanced Topics directory on my computer, but feel free to do this wherever you normally write your PHP code. We are going to create a new directory named namespaces. Next, let's make a new PHP file and call it project.php inside of namespaces. So here in our project.php file, I want to create a new namespace. To begin with, namespace declarations are at the top of your PHP file, right after your opening PHP tags and before any other code except for any declare lines. So first, let's add our PHP opening tags on line 1, and then on line 2, add namespace, all lowercase, and then project with a capital P, and add our semicolon. This declares that this file is now in a new namespace of project. Valid namespaces follow the same rules on naming of classes and functions and variables that you have seen elsewhere and forever in PHP. Okay, we have a namespace. What now? Now we can use that namespace at will. We can create a new PHP class called table. So in line 3, we'll add class table. Our table class can have a static method get. So on line 4, we'll add public static function get. Next, we'll want our get method to do something so we know it's working. Let's have it echo project.table.get \n for a new line. Don't forget your semicolon. We can create a whole new PHP file with a different namespace, but with the same class and method, and use both of these in sequence. First, let's select and copy this entire file. Next, we'll create a new file called app.php as well in the namespaces directory. We'll paste our copied code in here, and let's change the namespace name from project on line 2 to app. And on line 5, change the echo to read as echo app.table.get. So we have 2 files, both with the same method and class. Now let's use them. Staying in our app.php file, first we need to include our project.php file. So add on line 3, include project.php. And now we can tell our PHP file to use that external file at its namespace name. So the next line will read as use project \table semicolon. And if we finally add at the bottom of our file a line to call table : get. And now we can save all this and try running it via php /namespaces /app.php. We get a syntax error because our classes conflict with each other. That's easy enough to fix. Recall we can alias class names with PHP namespaces. So we'll go back to app.php and change line 5 to read as use project \table as project table. And line 13 can be modified to read as project table get. And now we can save this and rerun it. So we were able to both import code from a different class and see how to deal with when a specific class even conflicts with it. You can keep building on this to explore namespaces further. For now, we'll stop here and look into the most common way that you'll experience namespaces, via the use of Composer. Composer is a PHP tool that allows us to import code from other projects. We'll cover this as it relies heavily on PHP namespaces to do its job properly, as well as giving us the ability to quickly build upon already existing code in the broader PHP community. The Composer install process is pretty easy for both Windows and Mac users. There are specific instructions for doing this process on the Composer website at getcomposer.org. You can click on the Getting Started link. This provides you instructions to get this running on a Linux, Unix, OS X, or Windows machine. Follow the instructions for your operating system now. Please note the rest of this video and the course will assume that you have Composer installed and available globally. You can also find detailed instructions for installing Composer in the course Learn Cake PHP 3, The Basics. Now that you have Composer installed, we'll use it to install an open source package and work with it. First, where can we find some packages to install for our application? To do this, we can visit packages.org. From here, we can find a whole world of open source PHP packages, frameworks, and libraries for use in any application. Let's find one and install it now. If you enter in the search box at the top of the page, random, one of the first hits should be a package, Rike Random. Click the link for the package to get more information. Right at the top, we get the Composer instructions for installing this package. We can also see other information about this package. We can see the homepage for it, where to file issues, the version number, and any possible requirements, and much more about this package. So to install this package, first, copy the Composer require line at the top of the page, and then switch over to the terminal application on our computer. Now, we'll enter this command in our namespaces directory that we've already been working in. We'll paste it in and hit enter. Okay, a little bit of time is going to happen, and we'll have our random package installed and downloaded to our machine. Now, normally packages might have some set of dependencies to run and be included in. In this case, our particular package doesn't have any dependencies, so nothing else was installed. Now we can view our directory in our text editor. And if we look in the namespaces directory, we'll see we now have a new composer.json, a composer.lock, and a vendor directory. The composer.json file lists the specific requirements for our application. The composer.lock file details not just those requirements, but also the specific version. The vendor file includes our actual dependencies downloaded onto our computer. If we open up this directory, the vendor directory, we'll see there is an autoload.php. This is the file that we'll use to enable autoloading. Now, to use our random dependency, we just need to include this autoload file, and we no longer have to specifically require or include our specific dependencies for a page. We'll create a new PHP file, index.php, in the root of our namespaces directory. And in this file, first add our open PHP tags, and then add a line of code that is require __dir__ dot, and in quotes, /vendor/autoload.php. Please note that these forward slashes are for Mac OS X and other Unix-based systems. For Windows, it will be backslashes. What does this line do? It says to require including the autoload file that Composer generated. Next, we can add the line to use our namespace path to the random class provided from our dependency by adding on line 3, use Rike /random /random. And finally, on line 4, we can write out echo and in parentheses, new random, and outside of the parentheses, arrow, get random integer 1 through 5. This creates a new instance of the random class and calls the getRandomInteger method with the minimum number being 1 and the max integer being 5, and then echoes it. If we save this file and then run it from our terminal with php index.php, you'll see that we get a random integer from 1 to 5, and we can keep running this and keep getting a different random integer. And you're done. If you wish to explore Composer further, the website provides further documentation into what else Composer can provide for you. I wanted to focus on the fact that we can, with the help of namespacing, make it easier for you to use resources from the greater PHP community without a lot of work on your part. Composer is a great tool in your bag as an experienced PHP developer, and you should spend more time working with it and working with namespaces in general. At this point, you already have the files and directory that you started working on with PHP namespaces. You can either continue to work along in that directory, or you can use the provided exercise files to continue along. What is an interface? An interface is, quite simply, an abstract type that contains no data or code, but defines behaviors as method signatures. In other words, this is a class in which we can define methods and their signatures, but not define exactly how those particular methods are supposed to work. Well, why is this useful then? Isn't it enough to just define a class that defines the methods and implement those same methods and just make it easy to override if you need to, i.e. the normal pattern of how you've seen classes and objects in essentially any other project before? The short answer is, well, no. The longer answer is it becomes more and more useful when the users of your object's API can take both the implementation details and the signature details of your implementation independent of each other. Let's focus in on the problem that we're dealing with here. Interfaces are a tool in our wide range of tools to ship code that other people will want to interact with. Not the end result of that code of filling in a form and saving details or buying stuff, but instead as a framework like Laravel or Symfony or CakePHP, or even a general purpose library for interfacing, say, with databases or some external tool or service. Have some code that you're writing for a single project or a customer? Interfaces aren't something that you'll need to reach for very often in that case. They are useful when your customer is other programmers. Interfaces, for instance, are a great tool when you want to tell other programs, here's a thing that I'll be shipping. Want to use it? I'll respond to objects that implement this type of interface. What are some limitations of an interface? Well, like I said at the top, interfaces only define method definitions, but without any implementation details. If you want to ship implementation details, you could either write a real class that can be extended, or implement a trait, which we will discuss later on in this course. Interfaces, as you might have realized at some point, can only define the public functions of an object, which makes sense. An interface shouldn't describe the private or protected API of a class, only the public interface that other code would interact with and see. Here's an interface example along with the corresponding implementer class. Pretty simple. We create a file using the keyword interface, and then corresponding class implements that same interface. One of the real keys with an interface is that you can, instead of type hinting to an implementation and an exact class name, you can instead type hint to an interface. This gives you the ability to write an API and say, okay, as long as you provide an object that respects this public API, my code will do what you expect. Interfaces allow us to create more fluent and abstract APIs for objects over a standard inheritance model that you've worked with in the past. To create our first interface, you will want to add a new directory in our working directory called interfaces. In this directory, together, we will create our interface class and a corresponding implementer of that interface. So add a new file in the directory called interface.php. And we'll open up this file, and this is going to be our interface that we will implement. Start out like you normally would on line 1 with our opening PHP tags. And on line 2, we'll use the magic keyword interface and define our interface as table interface. That is interface, table interface. In PHP, interfaces are not required to have interface as part of the name of the interface. It's just good standard practice so you know what exactly this type of class is. Next, we'll add our opening and closing braces. Finally, we'll add a single method signature to complete this interface. On line 3, add a public function save, and it'll take one parameter, an array, data. And that's all we need. We now have an interface that we can import and then implement in a different class. So let's see the implementation side of our interface. To keep this simple and easy, we're going to implement this in the exact same file. Add a blank line or two, and on line 6, add a class table that implements table interface, and add in our opening and closing braces. And at this point, all we need is to write an implementation for our save method. First, let's see what happens if we say we implement an interface and we don't actually implement all the methods in that interface. In this case, notice we haven't implemented any methods from our table interface class yet. Save all of this and run the file from your terminal using php interfaces interface.php. PHP should throw a fatal error telling us we either need to declare the class abstract or actually implement what we say we are going to implement. Let's go back and actually finish up our work. Go back to the file and add the method signature, public function, save, array, data. And in this case, we'll have it just return a random string like foo. Next, outside of our class, on line 11, we can write the line echo, parentheses, new, table, arrow, save, and pass in an empty array. If you haven't seen the square brackets before in PHP, it is a feature called the short array syntax. It does the same work as declaring an array using the array construct, but obviously with much less typing. Save this file and repeat the process of running the code in your terminal. And you should see foo echoed out on the command line. There, we built an interface and built a corresponding implementer class in just a few minutes. Now that we have built a basic interface, we can explore extending our interfaces. Our classes can implement multiple interfaces, so we can write a class that implements both an interface for talking to a database, as well as logging some information. How easy is this to do? Pretty easy, in fact. So let's go ahead and do it. Let's go back into the directory and in the file that we were working on before in interfaces, interface.php. In here we had a table interface and a class table that implements that table interface. We're going to modify this to also have a new log interface, and our class table is going to implement both of those interfaces. So let's copy lines 2 through 4 and paste it as lines 6 through 8. Next, change the second instance of table interface on line 6 to be log interface, and replace the save method on line 7 with log. And instead of passing in an array data, we're just going to pass in a variable called message. And now our class table will need to implement both table interface and log interface. To add log interface, we just add a comma after table interface on line 10 and add log interface. What happens if we were to run this? Let's see. Save this file, swap to our command line, and enter the command php interfaces interface.php. And again, a fatal error. If our class is marked as implementing an interface, we have to implement all of every single interface we say we are implementing. So let's finish this up. Go back to our code editor, and we'll copy lines 11 through 13 and paste them as lines 15 through 17. Next, we need to change on line 15 the method call to be log, and the parameter for the method is no longer an array of data. Instead, it's message. And next, we're going to return that message value, and we're going to append onto it the new line string, which is in double quotes, \n. And then we'll copy line 19, duplicate as line 20, edit on line 20 our save method call to be log, and for our message value, we'll pass in the string space interfaces are awesome. Save this, go back over to our terminal, and we'll run this code using the command we earlier entered, php interfaces interface.php, and we get the string, foo interfaces are awesome. And you know what? Interfaces are pretty awesome. Multiple interfaces is a useful trick to provide smaller, more focused classes for tasks that need to be done across multiple classes and implemented in slightly different ways. Interfaces give us a really powerful tool for composing and building the APIs in our objects. So we've worked with some interfaces now and figured out how to use them. Does PHP provide some standard interfaces that we can use? Yes, in fact. There are 6 different interfaces that the PHP SPL or the PHP Standard PHP library provides. What is the PHP Standard PHP library? It is the standard set of libraries and classes that PHP provides for a variety of situations. The SPL should become one of your easy tools in your grab bag when you come across certain problems. We'll use the SPL a fair bit throughout this course. Let's first walk through what the SPL provides for us in terms of interfaces. The countable interface is the most basic interface and the easiest to use. It provides one method, a count method, that returns a single integer value. So this gives you the ability to say some object is countable in your application. You could have a collection class that stores a collection of orders or a collection of receipts. And you can have it implement the countable interface that gives you a count of the number of items in that receipt or in that order. Outer iterator is an interface to iterate over iterators. What's an iterator? Well, for now, let's just consider that an iterator is an extremely fast way of performing for each style loops over objects. So an outer iterator is an interface to handle the necessary code for looping over a collection of objects that themselves can be looped over. Recursive iterator is an iterator that recursively loops over iterators. Recursion and iterators mixed in together means this one is even harder to probably get a good handle on what exactly it means. For now, just understand that it's going to be useful in certain cases with certain types of applications. In general, though, you probably won't deal with this one too much. And oh yes, another iterator interface, the seekable iterator interface. This one is actually a bit easier to grasp. This means the iterator is able to seek to a current position. Like an array, we can both loop through each element one after another, or we can go right to an item at position 5. And for now, we're done with iterators. The next interface we have is the SPL observer interface and the SPL subject interface. These are companion interfaces that are designed to implement the observer design pattern. What is the observer design pattern? Good question. It means the pattern whereby you have a subject, and anytime something changes, it notifies its observer that something happened. This approach is used to develop event-driven programming loops. Change a user's password, and an event occurs that says to send an email informing the user that their password was changed. In this case, we have a subject, meaning the user model or user table, and we have an observer tied to whenever we change that user's password. So these were all useful interfaces, but do they actually matter? In your code, when are you going to actually use them? The observer subject interfaces don't tend to be as useful unless you are writing your own eventing system. The iterator interfaces, luckily for all of us, tend to be more useful as an implementation that we'll explore later on. The countable interface, that one is both useful and easily implemented. Let's implement it right now. First, we'll open up our text editor. We'll open up in the directory that we've been working with before, and we'll add a new interface to our table class in our interfaces directory in interface.php. So we're going to implement not just the table interface, log interface, but we're also going to add a comma and implement the countable interface. And on line 19, we'll add a new method, public function count. And recall, our count method has to return an integer. So in this case, we'll return the integer 10. Next, replace on line 24, where we're calling log, to instead call count, and remove our string that we're passing in. And that's all that we needed. We just implemented the countable interface from the PHP SPL. If we save this file, go to our terminal, and run it using PHP interfaces interface.php, we see that we get foo and the number 10 being returned as we expected. The benefit of this is now if we need the ability to return the count of an object, we can type hint to this SPL interface. And do we require an object to implement a known method with a known method signature, but leaving the implementation details up to that object and the programmer themselves? Traits can be considered a close companion to interfaces. Whereas interfaces include no implementation logic, traits, on the other hand, do include implementation details of a set of methods you want to be included in a series of classes. The main reason to use a trait over a standard inheritance model, i.e. to simply make a parent class with the shared methods and inherit from that similar parent class, is a lot of the time you don't want all your classes to inherit from the same base class. In other words, traits permit a style of horizontal code sharing as opposed to purely vertical code sharing. Logging is a typical example of where a trait's benefits are far greater than simply using standard inheritance. You need logging in probably a lot of your code, but not all of it, and you want to not have to rewrite the actual implementation details of how you log multiple times in your code base. So we have a standard model, view, controller application. Model talks to the database, view displays stuff to the end user, and the controller layer handles the coordination between these two other layers. We want to log in most of our model classes and some of our controller classes, but our views, on the other hand, have essentially no need for any form of logging. Where would this type of code live? Traits are our answer in this case. Traits are reusable methods that can basically be loaded into any class and be used whenever we need them, simply by including that class. Let's create a trait and see how they let us share code amongst other classes. To begin, create a new directory in our working folder called traits. In this directory, let's create a new file, trait.php, and open up this file. Start out like you normally would on line 1 with our opening PHP tags. And on line 2, we'll use the magic keyword trait and define our trait as log. Next, we'll add our opening and closing braces. Finally, add a single method signature to complete this interface. On line 3, add a protected function log, and it will accept a parameter, a message. One of the advantages of a trait over an interface is that the trait can provide methods with any visibility level. Recall, interfaces can only provide public method signatures. Next, you will have this echo the message variable and put a new line at the end. So line 4 will read echo, in quotes, the variable message, \n for our new line character. Okay, so that's the trait. Now, how do we use a trait? For that, we need a real class to actually be able to call our trait methods. Let's add a few lines and create a new class, table. Next, we need to use the trait. We need to gain our table class access to the methods available in the log trait. The PHP use keyword allows us to import the methods from the trait and use it in our class. So line 9 will read as use log. We are literally telling PHP, okay, use the methods provided from the log trait in this class. Now to PHP, it appears as if our log method is a protected method that our table class or any classes that inherit from table have access to. So go ahead and use it. On line 11, add a new method, public function save. And for line 12, we'll call our log method with the string save start. So it'll be this, arrow, log, and the string save start. And now we can repeat the pattern as we've done a few times at this point. Outside of the class, on line 16, add in parentheses, new, table, and then arrow, save. And that's it. Save this, go back to our command line, and run the command php traits, trait.php. And we see our log method was called because our passed-in message was displayed to the screen. That's the power of a trait. We can now use this trait in other classes without them needing to share a common parent class. PHP has a class of features for object-oriented programming you may not have experienced that much that will help you craft better software. PHP, like many other languages, has a feature set called magic methods. What is a magic method? Magic methods are so called because they let you add magic to automatically happen whenever you interact with your PHP objects. Magic methods are always prefixed with a double underscore. And in fact, PHP recommends you do not write any method names with a double underscore, as PHP may in the future add new magic methods. Magic methods are designed to give you the ability to do some work for free, or to have an override without having to dive into the nitty-gritty of the PHP internals. In essence, magic methods are the documented way for you to override some core behavior or have work happen at certain point in times in a PHP object's lifetime. Let's explore some examples, and this may become more clear. Sleep is fired when you serialize an object, and correspondingly wake up is fired when the object is unserialized. An example is you have a large object that when serialized has some state that doesn't need to be stored, because the object can retrieve it. Getting rid of this state before serializing it is probably useful. Correspondingly, you need to restore this information when unserializing an object. Wake up is the solution to that. Invoke is a super powerful magic method. It gives us the ability to create classes that are called invocable classes. In essence, we create classes that can have one method, their invoke method, and simply call that class, and the invoke method is executed. We have in essence replaced one-off methods with an invocable class, or wrapping up logic that might have been in a closure instead into this invocable class. Let's look at an example of how invoke works. Here we have a class, compare, with a single method, invoke, that compares two values and returns if they are exactly equal. We simply initialize the class, call the class, and pass our two values, and when we execute it, we get the result of either true or false. In this case, false. Simplistic example to be sure, but invoke becomes this very powerful way of wrapping up common bits of logic into classes that may be used across parts of your application. Imagine this code instead giving you the ability to check a valid order number for your system. It's useful in a wide range of places, and you just created a simple class to wrap up all that logic for you. Debug info is called anytime you execute var dump on an object. This gives you the ability to, for instance, provide help when someone is debugging your object, or add more contextual information that your object knows about but isn't revealed in a standard dump of the object itself. Those of you coming from the Java world, or C# will recognize your old friend toString. In PHP, it does the same thing. When you want a string representation of the object, this method gets called and gives you the ability to determine what string to return. The last few magic methods all deal with a similar problem. What happens when you attempt to examine or use a non-existent property or method name for an object? Overriding these methods gives you the ability to do really interesting things. Your objects can respond to method calls that it may not have access to at that point in time until something else first happens. You want a database system to be able to determine information about a query that hasn't yet run. These methods give you the tools to do that type of problem solving. Set and get are called when we attempt to set or get a property on a PHP object that doesn't exist. Imagine you have a library that deals with a price value, and you want to return that price as a string or as a float. You can write a magic getter and a magic setter for price string and price float, and alias them to access the price property in very short order. IsSet is designed to be called when we attempt to call empty or isSet on a property that doesn't exist. Its cousin, magic unset, is called when we call unset on a property that doesn't exist. The final magic methods that we'll look at are call and call static. Each of these is called when we attempt to call either a method in an object context or in a static context. So magic methods, what are they good for? Magic methods aren't a silver bullet for all occasions. Most of your code will never need a single magic method, and there are good reasons for that. Magic methods sometimes do weird things without your knowledge. That's how they work. They're magic. Magic stuff sometimes just happens without your knowledge or any warning. This stuff just happens. However, on those occasions where you really need the magic, they provide it. It'll save you a ton of time and provide you with a nice first-class solution to some very thorny problems. Constructors and deconstructors are the next advanced PHP object-oriented programming topic we should cover. Constructors and deconstructors are methods that PHP calls internally whenever you create a new instance of an object or destroy an instance of an object. They are another example of these magic methods. So what is a constructor? A constructor enables you to initialize some state for your object at the point that you create a new instance of the class. The benefit here is that you can pass in state to your object or your dependencies and have that state and dependency stick around for the lifetime of that object. Say you have a class that interfaces with an API, for instance a credit card processing system, and this API has the ability to toggle a debug mode. Anytime you create a new instance of this class on your staging and development environments, you can pass a variable that tells the class to toggle this flag for being in debug mode. You can also typically do things like inject your dependencies at this particular point. What about a deconstructor? If constructors create state, deconstructors do the opposite. They destroy state. The goal here is to destroy any other state that your object has that needs to be released. Common examples of when this is useful is classes that are designed to write out information to a file, or that hold a persistent connection to a database or some other external service. You don't want either of these connections sitting around after the class is no longer in use. So having a deconstructor remove the connection is a useful operation in these cases. So when does a deconstructor run? This is a fun question. It's relatively easy to know when a constructor runs. It's when you run the command new instance of some object. But a deconstructor, on the other hand, there's not always a clear time in which you say destroy this instance of a class. Once PHP knows there are no more references to that class, or that PHP itself is performing a shutdown, i.e. that the request is completed and everything is being completed on PHP side, that is when the deconstructor runs. There are some rules around dealing with parent constructors and deconstructors. If a child class has no constructor or deconstructor called, it will call the parent constructor or destructor. However, if a child class explicitly defines a construct or destruct method, then you have to explicitly call the parent's construct or destruct method. Let's play around with some of this now. Open up your code editor to the directory we've been working in up to this point. We're going to add in a new directory for object-oriented programming, and we'll label that directory OOP. Here in our directory OOP, we'll add a new file for structs.php. We'll add our open PHP tags, and we'll create a new class database on line 2. Here, we'll add a new public function, construct, on line 3. Remember that construct, because it is a magic method, has 2 double underscores at the front of the method name. This method is going to take one parameter that we'll call input. And on line 4, we'll echo the input var and add a new line to the end. So that's echo, double quotes, wrap our input var in curly braces, and then add the new line command. Let's add a few blank lines after line 5 and add a new public function destruct. Again, destruct is a magic method, so it includes the 2 double underscores at the front. Destruct here cannot take any arguments, as you might suspect, as destruct may not necessarily be called by you yourself. On line 8, we'll just echo destruct along with a new line. And then we'll finally get out of this class. And on line 12, we'll add object is going to be equal to new database. Save this and run the command php oop structs.php. Well, that was fun. We got a big PHP warning and nothing really worked properly. Let's go back to the editor and see what happened. Oh right, we needed to pass an input to our constructor. So where are the inputs to our constructor? They're the values we pass in between the object parentheses. Notice we are literally making a function call out of constructing or initializing our object. So on line 12, we'll add passing the string construct. And now let's save this and run it again. And here we can see that our magic methods construct and destruct ran one after the other. Our deconstructor fired after there were no more references to the object, and PHP cleaned up the instance of that particular object. Pretty simple. A singleton is a design pattern that restricts the instantiation of a class to one object, or just a single instance. hence singleton. Most of the time, you won't always need this, but this pattern becomes useful for objects that manage coordination or state over the lifetime of your particular application. So what do we mean by things that manage coordination or state? Okay, a general example is, say you have a class that loads in configuration and in essence determines the global state of your application. Are we in production or development? What is the database connections? Which time zone are we in? How should we format numbers? These questions need to be answered the same way every time for the entire time our application is running. Let's look at creating a singleton now. Making a singleton involves a fair bit of code, so I've gone ahead and done some of this for you already. In the course exercise files, there is a snippets.txt file. You want to open that, copy that, and paste it as a new file in your OOP directory that will save as singleton.php. Let's walk through exactly what this file is doing and how we're using our singleton. At the top, on line 2, we declare a normal new class singleton. Next, we have a protected static variable instance on line 6. This is the single instance of this class that we'll use throughout our entire application. Our first method is a static getInstance method on line 13. This method either returns a new instance of the class if none exists on line 16, or returns only the instance already created on line 19. We next mark the construct method as protected to ensure that the only way that a new instance of the singleton can be created via the new method is inside of the class itself. We mark the clone method, which we'll talk about a bit later, as private to ensure we can't create copies of the class as well. And finally, the wakeup method is marked as private as well to ensure that the class cannot be unserialized. Okay, let's look at a child of our singleton class. On line 51, we create a child instance called singleton child. This singleton child class is going to let us verify that we are only creating one instance of every class. On line 55, we can start exploring the abilities that this singleton pattern gives us. First up, we get an instance of our singleton and compare it to a new instance of the singleton itself on line 56. In this case, we expect it to return true, as every time that we get an instance of the singleton object, we should get the exact same object back. What about the child? Is the child instance the same as the parent instance? Well, no. On line 58, we get a new instance of the child object, and on line 59, we compare that child instance to the instance of the parent singleton. In this case, it should return false. However, if we again repeat the pattern of comparing the child instance that we've already created to a new instance of the singleton child, that should always return true. Again, singleton objects should only return a single instance of themselves for the lifetime of the entire application. Let's run this code and verify that it all works. We'll go over to our terminal application and run the command php in the directory OOP singleton.php. And yes, we get true, false, and then true. Exactly what we expected. Singletons may not be a thing that you'll always want to use, and you shouldn't use them all the time. It can be very easy to overuse. But if you ever find yourself needing to ensure you have only one instance of a class, such as for configuration or database connections, look to the singleton as a solution. Abstract classes can be thought of as a blend between a trait and an interface. An abstract class provides a way for you to write a PHP class that defines both just method signatures without any implementation, mixed with methods that have both a full signature and the implementation provided. Keep in mind what we discussed with interfaces. Interfaces are a way of shipping a pattern around which other people must meet. It's a way of saying you must respect and implement these functions. On the other hand, an abstract class gives you a way to say, you must implement these methods, but these methods I've already done for you. Typically, you don't want to ship an abstract class, as you don't want to tie other people's implementation patterns to your choices. In short, abstract classes are for you and your internal team. Interfaces are for other people and other external teams. So what is the point of an abstract class? Why use them? Let's go back to one of the first examples you probably saw of inheritance. You have a class automobile. Extending from that, you have a car and a truck and an SUV. Automobile, in this case, is an abstract class, a class that'll be implemented partially and only really makes sense in the context of being extended from in an actual car or truck or an SUV. Let's try a little more real-world and concrete example. We have a system that needs to deal with storing information about fruit. Our abstract class is the fruit class. It perhaps has some real implementation details when it comes to perhaps returning the calories or the weight of the fruit. But when it comes to eating a fruit, it differs a lot between different types of fruit. We also never actually would instantiate an instance of fruit, as it would be essentially meaningless for us. Instead, we have a concrete class, apple, grape, etc., that implement the rest of our abstract class and give us the real implementation to work with. Let's open our editor to the directory we've been working in and add a new directory for abstract. And in here, we'll add a new file for abstract.php. Now let's open this file and start this file like we've done now a fair bit at this point with our opening PHP tags. And to begin, we need a new abstract class. This one we'll call database. This is accomplished by using the keyword abstract in front of our class keyword and then the class name. So line 2 will read as abstract class database. Next, we'll add an abstract public method connect that will not take any inputs. So this will read as abstract public function connection. And we'll add a semicolon just at the end of this line. We don't need to have any opening or closing braces. Since this is an abstract function, it is not going to have any implementation details. On line 4, however, since we can have some real methods with real signatures and real implementation details, we'll add a public function disconnect. And on line 5, we'll add a comment to have it disconnect from our database server. Since we don't have a real database server that we're actually talking to, that we need to actually disconnect from, we're just going to leave this comment here so we know what's going on in this method, but not necessarily how we're going to do it. Notice, an abstract class is pretty easy to build. It looks very familiar and very comfortable to building a normal class. The only difference is we use this abstract keyword on any abstract methods and on the class itself. So let's build a real implementation class of this abstract database class. We'll add a few lines, and on line 9, we'll add class MySQL extends database. Again, notice, our database class is an abstract class, and we can extend from it just as we would normally with a normal inheritance model. And on line 10, we can add public function connection. And that's all that we'll do at this particular moment. Let's see how this all works. On line 14, we'll add db is equal to new database to see what happens when we initialize an abstract class. And on line 15, we'll add MySQL is equal to new MySQL. We'll save this, and we'll swap to our terminal, and we'll run php abstract.php. Notice here that we get a PHP fatal error. We get an uncaught error that we cannot instantiate the abstract class database. So this is one of the differences and benefits over a standard inheritance model. We never want to instantiate database. Database is an abstract concept without actual implementation details. We may want to type hint to an abstract class, but never actually create a new instance of this abstract type. After all, we're never going to talk to a generic database object. We're going to be talking to a MySQL instance or a SQLite instance, but never an abstract concept of the database itself. So let's go back to our editor and fix this by commenting out line 14. We'll save this and we'll rerun the command, and we don't have any issues at this point. Since we don't have any methods and our classes aren't actually doing anything, they'll just sit here and they're just kind of existing. You can see here how an abstract class gives you benefits over both a normal inheritance model as well as simply using a trait or an interface. Our abstract class is able to have a real implementation for the disconnect method. This disconnect method, rather than needing to be re-implemented in every other subclass, is able to be implemented at this high level, which is something that we couldn't quite solve with a normal interface. Let's turn our attention to some different patterns in PHP, away from architecture-oriented patterns to more day-in and day-out sorts of problems. First up is iterators. So what is an iterator? The standard definition of an iterator is an object that enables you to traverse a container. It is a solution to a super common problem in PHP and in just about every other programming language, looping over stuff. In essence, an iterator gives us the ability to perform a standard for each loop over a collection of objects in a programmatic and fast manner. At hearing this, you may be thinking, and that's impressive, why? Writing a for each loop is not particularly challenging. Putting stuff into an array and loop over it, done. What do you need an iterator for? Let's ask a different question. Do you often have multiple for each loops that you have to execute over a collection of data on different files? Say you have a series of steps that you have to perform for a set of data returned from the database. Probably at some point you have had this exact type of problem. Anytime you think yes to those types of questions, do I have multiple for each loops, a series of tasks, or a pipeline of work? Think about looking to an iterator to do that type of work. Iterators are great at these types of problems. But why an iterator over just a standard for each loop? Pretty basic reason. Iterators both tend to be faster as well as less memory intensive to a general for each loop. They also let us solve and design solutions to problems in much more elegant manners than a typical for each loop allows us to. The real trick with an iterator isn't so much just using them once or twice on a collection of stuff, but instead using a whole group of iterators to work through a large collection of objects. That's the real trick. Iterators are stackable, so we can write one iterator to solve one problem and then add on others to solve different problems. An iterator lets us write a class focused around one particular problem and write another different class for a different problem. An iterator, in most cases, is a class that implements these 5 methods. Current, being what the current value in the iterator is. Key, being the current key at the current point in the iterator. Next, being the next value in the iterator. Rewind, meaning to go back to the start of the iterator. And valid, providing a way to check if the current key has a valid value for the iterator. This sequence of operations is the iterator pattern. When we loop over the iterator, first, rewind is called to reset the iterator. Next, the valid method is called to ensure our value at the first position is valid. We call current or key or whatever our operation is being performed, and then next to advance to the next value in the iterator, and repeat the loop to valid and then current or key, next, and etc. So let's review our concept of an iterator. Iterator is a class that gives us the ability to loop over a collection of stuff, and it gives us the ability to build a pipeline of tasks. We can build an iterator that does some filtering, another one that does some organization, and another one that does some calculation. These iterators can then be stacked to loop over a collection of objects and the data that those objects have to filter, organize, and then calculate, all in a very nice pipeline. Imagine we have a collection of data. We need to first throw out any results that are bad. That's one iterator, a filter iterator. Another one that calculates the mean, another that calculates the mode, and another one that calculates the median. And perhaps in the future, we know we're going to have to add in more iterators to do more work down the line. That's our pipeline of work that our iterators can do for us. So let's build an iterator now. There is a code sample, snippets.txt, provided as part of the exercise files for this lesson. If we open it up, we'll see that it's separated into 2 files that we're going to create, an iterators.php section at the top and a data.csv section at the bottom. First, copy the section for iterators.php, navigate to your code editor, and we'll create a new directory called iterators. Next, we'll add a new file, saved as iterators.php. Paste in our code that we copied from our snippets.txt file. Next, we'll grab the data.csv section. And in our iterators, we'll create a new file and save it as data.csv. paste in this code, and we'll save it. Let's first look at data.csv and see exactly what it is. It's a pretty standard data CSV file, or a comma-separated value file. This means that we have columns of data that's separated by a comma. In this case, we have an ID, a name, note, and extra. Notice, each of our rows has some data on that particular row. Pretty simple, pretty basic stuff. Our iterators.php, on the other hand, is a little more complex. And this is the meat and potatoes of what we're going to talk about. First, we create a class, basic iterator, that extends the iterator class. Iterator is a PHP SPL class returning anything that is traversable, essentially meaning anything that is accessible using a for each loop, into an iterator. This class only implements a single construct method on line 4, which takes a path to a file, opens up an SPL file object for it on line 6, passes it to the parent construct method, and reads from that SPL file object. The SPL file object returns a traversable object that we are going to iterate over. At this point, we then pretty much use the iterator. On line 15, we set up a file path. We pass that file path to a new instance of our basic iterator. We take our iterator instance and loop over it using a for each loop. And then we just var dump that particular row that we're returning. Recall at this point the sequence that is happening. We rewind the iterator. We check the validity of the row. We then process the current row and then call next, move on to the next row, and repeat until we're done looping through our entire iterator. You want to save all this, and in your terminal, first change directories to the iterators directory, and then run the command php iterators.php. And that was it. We just built and ran our first iterator. Notice a few things here. Because our iterator isn't set up to filter anything, we iterated over every row, even the last row that is actually blank. For now, though, you can see the basics of our iterator working as we expect. We get an array of outputs, each array being the row in particular that we're outputting, and each element in the array being the value in that particular column in our data file. Recall we've talked earlier about how iterators are stackable. Because they are stackable, we can perform a series of tasks with a series of iterators. In this way, iterators become a much more powerful tool for solving lots of common problems in PHP. What sort of tasks? Data manipulation, calculations, data filtering and buffering, etc. Pretty much anywhere you have used a for each loop in the past, PHP iterators are a viable solution to replace them. So let's stack an iterator and build a second iterator to work with our basic iterator that we built in the last video. Open up your code editor to the directory iterators and open our iterator.php file. We'll add a few blank lines after line 13, and on line 15, we'll add a new class, filter rows. So it'll be class filter rows extends filter iterator. This iterator is using the filter iterator, which adds a new method, except. Except returns either true or false. True keeps processing the results, false ignores it and skips that entry from the rest of the iterators being run. You can imagine that our filter iterator simply drops any entries that return false. Next, let's implement an except method. On line 16, add public function except. Except doesn't take any inputs, and on line 17, we'll get the current row being processed with this arrow get inner iterator, which is a method call that returns the inner iterator, which itself is an object. So we can then do arrow current. This says get the inner iterator object. Once we have it, we want to access the current value of that iterator. We'll save this as the variable current. Now current is an array with keys for each column in our CSV row. And we know the last one has only one column for the blank row. So we can check if the count of the current is equal to 1 and return false, else return true. So add on line 18, if count of current is equal to 1, we want to return false. And outside of this, we'll simply return true. Now, how do we actually use this? That's the easy part. Add a new line after line 26 where we instantiate our basic iterator and write iterator is equal to new filter rows and pass in our instance of the iterator. And there we go. We just stacked our iterators. Notice all we have to do is instantiate a new instance of a second iterator and pass in the instance of the iterator that we've already previously built. If we save this, go over to our terminal application, once again, remembering to change into the directory for iterators, and run the command php iterators.php, we'll see that we no longer display that final blank row. Notice now all we have is the 4 rows of all the actual data that we have. You could keep building new iterators and stack them to provide more operations. For instance, you could build a new iterator, another filter iterator, to scan the data provided for each column and ensure that it is valid and correct. You could add in another iterator to scan each of the rows and match up the data for that particular column to the actual column name. Much like we discussed with interfaces, there are standard PHP iterators that we can use to build up our own iterators, provided for us from the PHP standard PHP library. We've already seen 2 of these. First is the iterator iterator, which wraps anything that implements the traversable iterator interface into an iterator. This is one of the most common starting iterators. A typical usage is just what you saw earlier, taking a SPL file object and converting it to an iterator for performing processing over it. Next one that we have already seen is the filter iterator. Again, this one adds an accept method that we can use to reject or include values in our iterator pipeline for further processing. Next is the array iterator, which again tends to be a pretty common iterator to start with. It takes an array and turns it into an iterator. It has a host of methods that are available to duplicate some of the functionality from an array to be useful with an iterator, such as sorting by key and checking if an offset exists. Directory iterator is a useful iterator to loop over the contents of a directory. File system iterator extends this to provide an iterator that loops over the contents of a directory and returns a new SPL file object for each item in the directory, whereas directory iterator returns a directory iterator instance for each item in the directory itself. Many of the SPL iterators have a recursive extension to them, and recursive directory iterator is our first version of this. In this case, the recursive directory iterator acts like the file system iterator, but will recurse through a directory structure. So we can use this iterator to, for instance, scan a directory tree looking for something, stack it with a filter iterator to shortcut as needed when you can ignore part of a particular directory. The infinite iterator will never stop looping over the contents of the iterator. Whenever it hits the end of the collection, it will just hit rewind and start back up. This is useful in cases where you might want to reduce a collection to a single value. This might be the solution to that particular type of problem. The limit iterator permits you to iterate over a sub-collection of items in your iterator. Want to grab the first 2,000 items in a collection and perform some operation before moving on? This iterator will let you solve that particular problem. The recursive iterator is an iterator designed to walk through iterators recursively. So you have a collection of data that has child information, for instance, related records that then need to be accessed and filtered and processed. This is the solution to that type of problem. You can build a recursive iterator to loop over and recurse into any particular data structure that you have and filter and process that data in turn. The last iterator we'll see is the callback filter iterator. Similar to the filter iterator, it allows you to filter items in an iterator. But what happens if you need to provide a solution for other people to use your iterators and for them to provide their own filtering methods? This iterator permits you to pass a callback that performs the filtering for your iterator. This type of callback filter iterator is commonly used in any packages or libraries that wrap up using iterators to provide access to collections of data. There are tons of other SPL iterator classes, but this collection of 10 iterators should cover most of the cases you'll hit in, day out use. Just remember, if you have a series of tasks that you need to perform on a collection of data, look to an iterator as a possible solution. Generators is a routine that is designed to control the iteration behavior of a loop, which may sound pretty simple, and at the most basic level, the conceptual idea is actually pretty easy to grasp. Let's look at an example, however. We want to provide a way to generate the Fibonacci numbers. Fibonacci is an algorithm used in mathematics to provide for the sequence f of n is equal to f of n minus 1 plus f of n minus 2. Or the number at position 3 is made by adding the numbers at position 1 and 2 together. This sequence typically starts with the seed values of 0 and 1 for position 1 and 2 respectively. So following this pattern, we add 0 and 1 to get 1, and to get the next number, we add 1 and 1 to get 2, and 2 and 1 to get 3, 3 and 2 to get 5, 5 and 3 to get 8, and so on. As an algorithm using the concept of a generator, it would look something like this. Let's walk through each of these pieces one by one and see exactly what's happening. First, we have a function Fibonacci that we are creating. Fibonacci defines two variables, the last and the current, i.e. our seed values. Next, it yields 1. What does yield mean? Yield is the heart of the generator, so let's pay attention to this. Yield at its most basic level provides a value to the code looping over the generator and pauses the execution of the generator. Think of it this way. Yield says, here code that called me, take this value, do something with it. While you do so, I will pause execution of the loop. After that external code is done performing whatever actions on the yielded value, the generator then goes on and continues performing its work. Back to the Fibonacci function. Okay, we yield 1, which means we pass it back to the exterior loop that is calling the generator, and we pause execution for any processing to occur. After we're done with that external processing, we enter our while loop, doing the math to produce our new current and new last values, and then yield the current value. The execution of our generator is in the for each loop. The value number we wind up looping over is our yielded values. So this kicks off the sequence, yields 1, pauses execution to echo 1, then enters our while loop, performs the math, yields the next value in the sequence, pauses execution to echo that value, and repeats the while loop until we tell it to quit. Well, how do we tell the generator to quit? A generator will quit when you return a value. A generator will only return a value when we're exiting. So to exit a generator, say you want a generator to end after displaying the first 10 Fibonacci values, you just return an empty value and the sequence will end. The example looks like this. With just a little bit of changes, we can turn our generator from an infinite loop into one that we can pass a value into and exit after we reach some particular position. Now, whenever we hit the position we pass in, the generator will skip and exit using the empty return. A generator can also yield a classic array-style key with a value pair. And again, some minor modifications, we can change our generator to return a key with the value. Notice in our while loop, we can yield both the value I as well as the current actual value for the Fibonacci sequence at that point I. Our implementation of using this Fibonacci function looks like this. We pass in Fibonacci 6 as key is equal to value. That key again is yielded back, and our value is also yielded. And we echo the key and the value. So we get 0, 1, 1, 1, 2, 2, 3, 3, 4, 5, 5, 8, and 6, 13, and so on and so forth. As you might expect with PHP, you can even yield a value by reference. This is performed the same way you yield a return from a function, prepending an ampersand to the front of the generator function. So in this case, we're passing in a value into countdown, and we're referencing it from outside the generator and manipulating the value. In this case, we're building a list that counts down from 3. Finally, generators can also yield a null value. These null values do get an automatic key applied to them. This can be useful for building up, say, a collection where you occasionally want a null value returned, as opposed to a real value returned. Don't feel overly intimidated by generators. They are a pretty complex topic to work through. It's taking a lot of the complexity that's already in an iterator and hiding it behind some syntactic sugar. The trick is to understand that yield acts like a return, except rather than stopping the execution of the loop, only pauses it for some operation to occur. Let's begin to build our generator by working in our text editor. First, we'll need to create a new directory, generators. Next, we'll add a new file in our generators folder called generators.php. And let's solve a relatively simple problem, fizzbuzz. If you haven't heard of fizzbuzz before, it's a problem whereby you loop over a collection of numbers and output fizz if the number is perfectly divisible by 3, and buzz when it's divisible by 5, and fizzbuzz when divisible by 3 and 5, such as 15. Let's start with our open PHP tags on line 1. Next, we'll add a function fizzbuzz, which will take a single input value of limit. Okay, next we'll add our incrementing value on line 3 as I is equal to 0, as our results from the generator will start from the numeric index of 0. Next, we'll start our loop with while I is less than or equal to limit. After that, we want to perform our check and yield a return value. First, we'll set a yield var equal to null. Line 6 will read as if I modulus operation of 3 is equal to 0, we want to set yield equal to the string fizz. Line 7 is going to look very similar. It's going to be equal to if our variable I modulus operation with 5 is equal to 0. Then we want to set yield is equal to the string buzz. On line 7, we need to modify it, however, to actually append buzz, rather than simply setting an equal to buzz. In this case, because if our value is 15, we want to output the value fizzbuzz and not just buzz. Line 8 is where we will yield our variable yield. Line 9, you will want to increment your variable I. We want to set I plus plus. And outside the while block, an empty return. Recall, an empty return will exit our generator. Finally, we can actually execute this by calling a for each loop over the results of the method. So add a few lines after the closing of our function. And on line 14, we'll enter in for each fizzbuzz, passing in the integer 25 as key set equal to value. Add in our opening and closing braces for our for each loop. And on line 15, we can echo the key and the value and a new line. So we'll add echo, and in double quotes, key, and then value, and then a new line command. Now if we save this, go over to our terminal application, and run it with PHP generators, generators.php, you should see the numbers from 0 to 25 printed out along with the appropriate string after them. We can see that 3 has fizz, 5 on the other hand has buzz, and we can see that the value 15 has fizzbuzz. So that worked out for us. Now this example is a little contrived. Fizzbuzz is kinda a silly problem and not one you'll encounter very often. But hopefully working through this problem has shown how to use a generator and how a generator can solve certain types of problems for you. Password hashing is the standard technique for storing passwords for a shared service, like a web service. The goal with password hashing is for storing data in a one-way format, whereby you, the author of the program or the software, cannot know what the original data is. But if someone gives you the original data, you can turn it into that final form. So here is an example of a password hash. We have the string testing, and it gets turned into this big long string, $2y, $10, $VRBG, and so on and so forth. This is a hashed value. We can easily turn our string testing into this value, but doing the reverse, taking that big long string and figuring out what produced it, is essentially impossible, or at the very least impractical as a regular matter. So at this point, you may be wondering why you should hash passwords as opposed to just encrypting them or storing them in plain text or storing them in your own custom format. In that case, you should watch the course CompTIA Security plus Exam Prep SY0-401 on cryptography to get a clear overview of the fundamentals, both of what exactly hashing is and why you should do it with the data you need to validate but don't want to have access to. So what about PHP? For the longest time in PHP, we had the crypt function to hash strings, but it required the developer to be both smart and knowledgeable about cryptography and to understand things like how to use a salt, choosing the right algorithm for hashing your passwords, and even figuring out how to update passwords as time went on. Plenty of developers messed up this basic security task, and it's not their fault. Well, that time has passed. PHP now has a new function, password hash, available since PHP 5.5, that provides a pretty much cannot mess up solution to hashing passwords. PHP took one of the most common cryptographic problems and gave us a pretty foolproof solution. So password hash takes 3 inputs, only 2 of which are required. The first is the password that you're hashing, the second is the algorithm to hash the password, and the third is an optional array of options. Password is pretty simple, it's simply the basic string. The algorithm parameter takes an integer. However, PHP provides a few constants to make this easier to work with. The first is the default algorithm used. The second is to use the bcrypt algorithm. Both of these, as of today, actually wind up using the same algorithm behind the scenes, the bcrypt algorithm. The goal here, however, is to use the password default algorithm and then upgrade your passwords automatically as new algorithms come out that offer better security as hardware advances. In other words, if you stick with the defaults and add a little bit of code, your passwords will automatically be upgraded and rehashed as security advances occur and PHP gets those particular updates. The options parameter is based upon the algorithm in question. As there is only currently one algorithm supported, there's only one supported option: cost. Think of cost as a decision that you make and how much work do you want to occur when hashing a password. The standard cost is 10, and in general you should only set this number higher. There is technically a second option, salt. However, starting with PHP 7, this is deprecated and should not be used. And even in PHP 5.5 and above, when you leave this empty, the hash method will apply a random salt for each password hashed. Let's build a password hasher in a minute or so. First, open up your code editor and add a new directory, hash, and a corresponding file, hash.php. Next, we'll add our open PHP tags on line 1, and on line 2, we'll add echo password underscore hash, pass in the string testing, and then pass in the constant password underscore default. Save this and run it from your command line with the command php hash.php. And look there, we see our testing value hashed and outputted. If you paid lots of attention, you may have noticed that the string produced doesn't 100% match what we saw earlier. This is because of that random salt being added into the hash. Rerun this command, and you'll see that we produced a different string. Notice that this is about as simple as you could possibly imagine having to do work to hash passwords. PHP gives us this great tool for password hashing, so I better not come across any more manual password hashing or your own crypto implementations in any more code bases. Great, so we now know how to hash a password. What about verifying that a password actually matches? Well, there is indeed another function dedicated to just that problem. Password verify takes a password and an already stored hash and compares the two and verifies that one matches the other. So let's open up in our text editor the hash directory and hash.php And we'll modify line 2 to first store the value as password. Next, we'll echo the value of password along with the new line. After that, add a line to check foo against our password value. So line 4 will read as matches is equal to password underscore verify, the string foo, comma, and our password variable. Notice what password verify is doing here. We don't have to tell it which algorithm to use. We don't have to tell it the cost. We don't have to pass in any options. You only have to pass in the string that you want to check and determine if it matches an already hashed value. On line 5, we'll echo the string matches and a new line. And line 6, we'll check the real password string testing. So we'll copy lines 4 through 5, duplicate them as lines 6 and 7. On line 6, replace the string foo with the string testing, and that should be it. If we save this and rerun our file using php hash.php, we get a return of our new hashed value. We get a false, which because it's turned into a string winds up not displaying to our screen, and then a true result, i.e. 1, for verifying that our passed in value is equal to our hash string. That was pretty easy. And notice how it's essentially foolproof to ensure you can both securely hash and verify passwords. So we've seen how to both hash passwords and verify passwords, and we've seen that both of these operations are pretty easy. But surely checking if you need to update the hash for a password as algorithms change or as you update the security of your system is going to be challenging. Not quite as much as you might think, though it is going to be slightly more code than we have written up to this point. Let's open up our hash.php file in the hash directory. First, we're going to leave lines 1, 2, and 3 alone, and we're going to erase everything else. At this point, envision our database is providing that password variable. Okay, so this is the value we have in our database, and this is our out-of-date hash that we need to update. What happens next is we call a method password needs rehash, which takes our hashed password and the next 2 arguments from password hash, the algorithm to use, and any options for that algorithm. To do this in particular, we're going to pass in a new cost value. Line 4 is going to read as if, calling the password needs rehash function, passing in our password variable, passing in the constant password default, and then we're going to pass in an array, which is going to have a key cost, whose value will be 12, different from the default of 10. At our opening and closing braces, recall, cost is basically the difficulty level for how hard the hasher works at hashing our passwords. So basically, we're saying right here, we're going to keep the algorithm the same, but we want to make the computer do a little more work when hashing the algorithm. Then this needs rehash function will return true on the password string needing to be rehashed. So then we can call new hash is equal to password underscore hash, pass in the string testing again, pass in our constant password default, and then our array with a cost key and the value equal to 12. And on line 7, we can echo this new hash value and our new line. If we save this and go over to our terminal and run it using the command php hash.php, and if you look closely, you'll see that the 2 echoed strings don't match. One of the differences you might notice is after the $2y, there's a $10 in the first hash and a $12 after the second hash. Notice that's our cost value. In the first case, we have that cost value of 10 versus the cost value of 12. That's how bcrypt knows the cost associated with the algorithm. So password hashing, password verification, and even an easy way to both know when you need to update your password hashes and a good pattern to solve that problem. Not too bad, PHP. You've given us a really easy to use tool to solve some really common security problems. I've mentioned in this course once or twice the idea of type hints without actually explaining what they are. Let's look at the concept now. Type hints or type declarations, which I'm going to use going forward, as that is how the PHP manual refers to them, are hints to the programmer and to the PHP runtime that I require something that corresponds to a particular type. If I don't have a value that corresponds to this type, bad things are going to happen. So what do I mean by a hint? Recall earlier we talked about interfaces and abstract classes. That's what we get to do here. We can add a type hint or a type declaration to a specific class or interface. So in our earlier work, we can type hint to our abstract class table and ensure that we have whatever methods our abstract class or interface or even a real class provides and work with. What happens when you pass something that doesn't match the type declaration? We call this a mismatch. In PHP 5, a recoverable fatal error will be thrown, and starting in PHP 7, a type error exception will be thrown. So what do type declarations enable? What real-world benefit does it offer over just accepting anything? Your software probably isn't designed to deal with every type under the sun. Imagine wanting an array and you get an object, or you want an integer and you get a string. Weird stuff would happen with your code. Type declarations are an easy solution to that type of problem. So how do type declarations work? You want to add the type that you want to hint to right before the variable name of the parameter. If you don't want a type hint, simply don't add a type hint. In this case, DB will be required to be an instance of the namespace class app database database. Options, on the other hand, will be required to be an array. And finally, foo, we can pass anything to it currently. A class, an array, an integer, a Boolean value, a string, etc. Let's talk about the elephant in the room, PHP itself. PHP itself is a dynamic language, which means it doesn't do strict type handling. So if you have a string and try to read it as an array or an integer, PHP will do magic stuff, and you'll be able to access your string as an array or an integer without doing type conversions like you would if you worked with a language that was more strict about types, such as Java. This feature of PHP is referred to as duck typing, i.e. if it acts like a duck and quacks like a duck, regardless of what it looks like, we can treat it like a duck. So our strings, because they can act and quack like an array, we can treat it as an array, even though it's technically a string. This natural dynamism about types is useful until it isn't. Truthfully, in a lot of cases, that dynamism in PHP is useful and valuable. It allows you to solve some problems in interesting ways. And accessing a string as an array means you can quickly access the fifth character in a string by treating the string as an array. In Java, this requires a, to be sure, language-provided method call, but a method call nonetheless. Other times, you compare a string to a Boolean and you get that it's true, and you really just want to wonder at PHP how this string, blah, evaluates to a Boolean. Maybe you almost never care about that, but sometimes you are going to care about different types. Here's the real talk. Adding in type declarations won't solve every problem in your codebase, but it will mean you just don't have to deal with a class of problems because someone didn't read the documentation close enough to realize they needed to pass an array and instead pass a string or something else. You should still do other checks like unit testing and such to verify your code works in oddball scenarios, but type declarations will save you time and energy at certain points. Type declarations is where interfaces become super powerful. Since you can type hint to an interface, you can write code such that you can tell other developers and PHP, as long as you implement something that implements this interface, it'll work just fine. If you don't, bad things are going to happen. So what all type declarations can you provide? You can provide a class or an interface, which says the pass object must be an instance of whatever class or interface is provided. Self says this must be an instance of the same class of whatever class this particular method is defined in. Callable says that this must be a value that PHP can execute, so an anonymous function or closure that we'll explore a little later on, or something similar that PHP can execute. Array obviously says this must be an array. In PHP 7, some scalar type declarations were added, so we can ensure a value is a Boolean, a float value, an integer, or string as well. I'm not going to say you should or should not use type declarations in your code. Type declarations offer, in my humble opinion, some real benefits, especially when it comes to code that will be released for other programmers to use and write against. I personally use type declarations in my day-to-day software. You probably should too, but there is no reason you have to use type declarations. So if you don't like type declarations in general, you are really going to dislike strict type declarations. Strict type declarations are a way for us to remove even more of the dynamic features of PHP. Recall in the last video, I mentioned that PHP added some scalar type declarations. Also recall that we discussed how PHP, being a dynamically typed language, we can treat some types as other types without any real effort. This attempt to use floats 1.5 and 2.5 in our sum method will wind up having them being silently converted into the ints 1 and 2, which may be what you want to do, but sometimes it isn't. Is there a way to tell PHP, so when I mean an integer, I mean I really must have an integer? In fact, there is. Welcome to the declare syntax, which you have probably never used but has been hanging around in PHP since PHP 4. In the past, it was used for two specific cases, one to basically walk through code every time the parser ticked, and the second to specify the encoding of a file. Both were pretty unusual cases. I can't recall ever seeing declare used before PHP 7. In PHP 7, we gained a new case, to declare strict types. This strict types enables for the file that the declare statement was added. It says for any function calls made inside of this file, use strict typing when looking at the scalar type declarations. It does not apply for any function calls made to an external file or made into that file. I'm going to explain this in further detail, so don't worry if that sounds a little confusing at the moment. Let's look again at our example. Here's our first initial example, right? We have a sum 1.5 and 2.5. In this case, we're going to return 3. Because A and B are going to be silently converted to integer. If we add strict type declarations to this file, instead we're going to have a type error displayed rather than actually executing the sum function. Here, we have function.php that has strict types enabled and caller.php does not. What happens? This actually returns 3 because PHP will always defer to the caller when looking to evaluate strict types. And if you think about it, this makes sense. If we defer to the function author or function.php, any code published possibly produces a ton of breakage if the people using it do not want to use or are not used to following strict typing. Here again, since we defer to the caller, the call to sum would throw an error as it fails to strict typing in caller.php. There is, however, one special case with strict typing. Sorta. If you declare requiring floats but pass an integer, this will pass an int, as an int is really just a special case of a float. Special note again here, if you decide to use strict typing, this strict typing declaration must be the first line of your file, and every file. Type declarations already give you a stronger idea about the values your methods are accepting. Strict type mode gives you an even higher level of assurance about the code being used and produced. You are adding assurances that you are not just passing values that could possibly match the type in question, but that they are the exact scalar type. And that really might matter. Even our example with the sum function passing a float versus an integer really does matter. Then again, strict typing can be kind of a pain and a hassle. So like all things in PHP, it's an optional feature. And you know what? If you use a library or package that uses it, because it always defers to the caller, you'll never know or care if the authors of the library enable strict typing. Return types is an extension of what we've already seen with type declarations. In this case, we specify the type that a method will return. Quick aside here, return types are only available in PHP 7 and above. So if you're only working with PHP 5, this is just a tease of some of the benefits of PHP 7. This is what a return type looks like. In this case, we specified this method, getUser, will return an object that can be typed as a user interface object. Pretty simple, right? Notice we defined the return type after the method call with a colon and the specified return type between the closing parentheses and before the opening curly brace. So what types can we declare? Recall our type declaration options that we have: class and interface, self, callable, array, bool, float, int, and string. Our return type declaration options are class or interface, self, callable, array, bool, float, integer, and string. The list of return type declaration options is exactly the same, and this makes sense. It would be confusing if you could pass a type into a method and not declare that same type to be returned. The goal is similar to function type declarations, to provide for you to know what the return type of a method should be and ensure that your software meets that particular decision. What about strict mode? Does that affect return types? It does indeed. PHP will, when strict types is not declared, coerce values to that particular return type. And when strict types is declared, it will throw a type error on a mismatch. There is a catch with child methods. When defining function type declarations, a child method that defined a different type than the parent would cause a PHP strict error to be thrown. With function type declaration returns, the return type must match, else you cause a fatal error to be thrown. Confused a little bit? Let's clarify that some. So in this case, we have a function type declaration different between the parent class table, which accepts an array, and MySQL, which accepts a Boolean value. In this particular case, we'll get a warning displayed. When we attempt a similar action only with the return type declaration, we get instead a fatal error. Table declares it's going to be returning an array, and the child class MySQL says it will return a bool, and well, that's frankly a problem for PHP. However, if you're working with a framework or a library that doesn't use return type declarations, for instance because they have to support PHP 5, and you really want to add return types to your code, maybe it's even part of your internal standards, feel free to do so. Child classes can easily add type declarations. This right here is totally valid PHP 7 code, right? And this is what we want. For instance, maybe you are writing an interface. You shouldn't tie down people's implementations of an interface to decisions that you have made about what particular returns each method has. So your interface can instead just leave out the return types and let the implementers of the interface decide the best decision for themselves. So what about null return types? Well, so as of today, you can't do them in PHP. There is no such thing currently as a nullable return type declaration, or for that matter, a nullable type declaration. However, this will change in PHP 7.1. There is an accepted RFC to add nullable type declarations. Taken directly from the RFC, nullable type declarations will look a little like this. The idea is if a type is permitted to be null, you put a leading question mark on the type declaration and you flag that return or input as possibly nullable. So today, you don't have this ability. However, in the very near future, this will change. At the end of the day, the type declarations can be a real benefit towards helping people reduce the incident rate of bugs. This doesn't mean every developer will use them or even want to use them in every case. You should, however, try them out. And next time you catch yourself passing a float when you really meant to pass a Boolean, think about adding a type declaration. Let's talk about PHP closures and what exactly a closure is. A closure is an anonymous function. It's called an anonymous function because it's a function that doesn't have a name attached. So here's an example of a closure in PHP. Notice there isn't much practical difference between this function and a normal function, except we've dropped the name from the definition of the function. Otherwise, it starts with a function keyword, the opening parentheses, the opening curly brace, the actual function code, and a closing curly brace. We add a semicolon after the closing brace, as this function is being set to a variable, func. We then echo func, and it executes our function. You may be familiar with the concept of closures from JavaScript. In JavaScript, however, they are a slightly different concept, so you'll have to keep these two ideas separate. PHP has a closure class that gets returned internally when we create an anonymous function. So our earlier example, we actually return a reference to a behind-the-scenes created instance of the closure class. A simpler way to think about the concept is a closure is a callable class, similar to the invoke concept, but instead we bind the parameters manually as well as limit the scope to only itself. Let's talk about that scope concept for a second. So when we talk about scope, we mean the part of our code that a variable is valid and defined for. In this case, if we try to use the variable var in our closure, it's undefined. Why? Because the closure only has its own scope. It knows nothing of the outside world. Any code you write outside of the closure is for all intents and purposes ignored. Well, if a closure doesn't know of anything outside itself, can we pass in variables to a closure? So yes, you can pass a variable into a closure. You can add the variable to the function definition, much like you probably expect, and just pass it in. What if we don't want to pass a variable in? What if instead we want our closure to expand its scope to be able to peek out into the broader world of the rest of our code? Can we just tell our closure to have knowledge about this particular variable? There's a keyword, the use keyword, that we can use to tell our closure, okay, use this variable from our local scope and bind it to your scope. In essence, we import the variable for use into the closure itself. Quick note here, the variables passed in via the use is only by value and not by reference. So if your closure modifies the value of the variable being passed in via the use, it's not actually passed back. Let's go through a quick example of this concept. So var is passed by value, and even though our closure modified var to instead be the string function, outside the closure it's still the string closure. We could pass the variable var by reference and then it would be modified. Typically though, this pattern doesn't actually show up very often. So what are closures useful for? Actually, there are a fair number of reasons to use them. One of the most common is to enable a style of programming in PHP called functional programming. Functional programming is a programming paradigm in which you run typically mathematical-oriented functions that do not change state or data. Think about it this way. In a typical object-oriented programming paradigm, our objects contain both state and methods. In particular, we have state, typically properties, and then we have methods that we can run on those particular objects and modify the state at runtime. That state can change the outcome of a particular method. Functional programming, to keep it simple, is designed to not have state. Method foo with an input of bar will always have output baz, regardless of everything else going on in your application at that point in time. Well, what else can we do with this sort of thing? Well, actually a lot of things. Some common ones are one-off functions to handle some simple little problem that you will use literally nowhere else. Hello to a closure. Need to set a stable reference to a function call from an object that you later won't have access to, but still need the function call? This is a closure. Remember our iterators from earlier in the course? Lots of the iterator style libraries you will see out there will let you pass closures into them to write your own code that then gets executed on the iterator collection. These are all examples of a pattern called the strategy pattern. The strategy design pattern is a pattern of selecting a function or the behavior of a function at runtime. Closures are a useful technique to apply to a lot of interesting problems. Hopefully you'll find after this to use them with skill and ease. So let's go ahead and build the closure. First, we'll make a directory closures. Next, we'll add a new file, closures, in our closures directory. And we'll start with a common first example of a closure, using the array filter method to filter an array of integers. So in line 1, we'll start with our open PHP tags. Line 2, we'll create an array with the numbers from 1 to 9. Next, we'll use the array filter method, which takes 3 parameters, but we only care about the first 2, an array to iterate over, and a callback. Our callback in this case will be our closure that will return true for all even numbers. So line 3 will read as the variable out is going to be equal to array underscore filter and passing in our array. Next, we'll begin by adding our closure. So this will start with a comma. We'll add in function, pass in a variable item. The item variable in this case is just the current value of the array at each particular index as the array filter function loops over each result. Next, we'll add our open and curly braces for our function call. And line 4 will read as return, and then inside of parentheses, the variable item, modulus operation with 2, equal to 0. This says to return true for all even numbers. On line 5, we need to add in our closing semicolon, as this is still just one single PHP statement, starting on lines 3 and all the way to line 5. Next, we'll add a print R statement on line 6, and we'll print out the variable out. And on line 7, we'll print R the array to demonstrate that the array variable did not get modified. Finally, we'll save this. We'll go over to our terminal application, and we'll run it using the command php closures.php. And you should see 2 arrays printed out to the screen. Notice the first one has only even numbers, and the second is still our original unmodified array. Let's add a tiny bit more complication to this. Go back to the code and our code editor. We can copy and paste lines 3 through 6 and paste it as lines 8 through 11. Take the anonymous function we wrote, and we're going ahead and extract it out. So copy that function and place it on line 8. Now we're going to save that closure to a variable called filterfunc. So we'll add filterfunc is equal to our function item, and add our now needed semicolon to the end of line 10. And here we can modify line 11 to instead use our variable filterfunc that is a reference to our closure. Next, let's modify this instead to return the values in our array that are odd by changing line 9 to return item modulus 2 equals 1. Save this, and if we go back to our terminal and rerun the code, you'll see our closure is filtering our array of integers by both evens and odds. And that's it for basic closure. Okay, so we have our basic concept of closures down. Let's do something more interesting with them at this point. Remember our magic invoke method we discussed earlier? Invoke is a way to turn a class into a closure. Invoke winds up being one of the more common ways that you'll see a closure style approach in PHP. So let's build an invocable class. Let's add a new PHP file, invoke, to our closures directory. And let's create a single use class to validate if something is a real positive integer, i.e. we pass a value that can be evaluated as a whole positive number, such as 1, 5, or 7, as opposed to, say, -1 or 2.3. First, create a new class after adding our PHP open tags, of course. This class name will be called isPositiveInt. Next, we'll add an invocable method on line 3 that accepts a single input. This input is going to be a value. And on line 4, we can evaluate whether or not value is a positive integer in a single line using return, parentheses, another set of parentheses, and inside of that second set, int, then value is equal to value, our double and value is greater than 0. This first casts value to an integer, compares it to the original value, and ensures that they are equal. This ensures that if we pass a string 5, it will match the integer 5, but not the float 5.1. We then also ensure that the value is greater than 0. Now we can go ahead and use this. So on line 7, after our closing brace for the class, add invoke is equal to new is positive int. Notice we're creating a variable that is a reference to our class. Next, on line 8, add var underscore dump, pass in our variable invoke, and we're going to treat it like a function call. So we can add parentheses and then pass in the value that we want to evaluate. In this case, we'll pass in the positive integer 5. Next, copy line 8 and duplicate 4 times. So we now have 5 copies of the line. First, we'll change the value on line 9 to be the string 5. On line 10, we'll pass in the value 5.0 for a float. Line 11, we'll pass in the negative integer -5. And line 12, we'll pass in the value 5.1. So when we run the first 3, they should all return true, as they wind up being equivalent to a positive whole integer, and the last 2 should be false. If we swap to our terminal and run like always with php closures invoke.php and hit enter, we see that we get 3 true returns and 2 false returns. So notice how easy this gives us to write off these sorts of single-use classes, to especially do work like execute some single-purpose logic or use it to perform validation. You could also stack this with iterators to build an iterator that has an execution step that calls out to an invocable class to execute some logic for each piece of data. Our final topic for this course is covering exceptions. Exceptions are a way to trigger an error state or condition in some part of our application and let another part of our application handle that problem. A typical exception flow is an error condition is raised. At that point in our code, we throw an exception. The caller of our code that threw an exception has a try-catch block at some point. These try-catch blocks are blocks of code that say to run this, and if an exception occurs, catch it and handle it in this particular way. So we catch it at this point and deal with it in some way. What happens if our application throws an exception and we didn't catch it? Well, in some cases, your framework might deal with it and display an error message to the end user. In the worst case, the exception, if uncaught, will cause a PHP fatal error, which shows up to the end user as an HTTP 500 style error. So what are exceptions useful for? Well, you'll have fairly often conditions in your application in which some module will throw an error and you'll want to deal with it. Typically, methods have a limited subset of return types and what you can be expected to deal with. Exceptions give you a broader range of dealing with errors in your code. So we have a method in which we are finding a record from our database and we expect it to return the matching user object, except it may not find the record. Maybe it doesn't exist, or the user doesn't have permissions to access that record, or any number of other reasons. If all we look for is either the user object or a false value, it's a limited set of decisions we can make in a failure case. We don't know what caused the failure of returning the object, just that it wasn't returned. Exceptions are trying to give us more options towards solving whatever problem raised the particular exception. So here's an exception. We have a method, process credit card, that processes a credit card, and we place it inside of a try block, and outside there is a catch block that says to catch an exception E, and then we deal with it by logging the exception message and returning false. The exception class is the base for all exceptions in PHP 5 and all userland exceptions in PHP 7. By userland, I mean everything you, the user of PHP, owns and can change, versus the internals of PHP. PHP 7 changed some of the handling for exceptions and errors, but we don't have to worry about that at the moment. Exception classes have a constructor that takes a message, an integer code, like a Unix error code, and a possible previous exception. You can get the message, the previous exception, the code, the file, and the line where the exception was thrown, as well as a stack trace of the path your code took to get to the exception. In PHP 7, a new interface, Throwable, was created. Throwable is designed around the concept of anything that can be thrown will be thrown with the throw syntax. So exceptions basically. Also in PHP, a new class, Error, was created. Error is the base for all internal PHP errors. This means in PHP 7, what used to be a fatal error is now a standard error that can be caught and dealt with. Though truthfully, most errors that PHP raises are actual problems in your code and shouldn't be ignored or skipped over. Exceptions should be used to derive context for a failure case. You should not handle general cases or throwing exceptions for a normal condition in your code. A common example here is looping over a set of stuff. When you hit the end of the array, it's not an exception, it's just the end of the loop. There's no need for an exception in this case. You can have multiple catch blocks when catching an exception. So if you have a block of code that throws multiple types of exceptions, you can catch each one and handle it differently. The first catch block that matches the exception type will be used. Note, since all userland exceptions derive from the base class of exception, exception will catch everything that you throw. PHP 5.5 added the concept of a finally block. The finally block is a block of code that will always execute, regardless of an exception being raised or not. The finally block can be used in the place of a catch block or after a catch block. In essence, the finally block gives you a chance to deal with any last things before returning to your normal programming flow. Notice what I said just now, the normal programming flow. Exceptions are explicitly a rare case. You shouldn't need or have exceptions scattered throughout your code. They're designed to catch the rare occurrences in your code. One of the most common places they'll be used for is when you call out to a library or an external service that is performing a fair bit of work and that has a variety of returns that you'll need to deal with. So together, let's build our first exception. To do this, we're going to add a new directory, exceptions, and a new file in that directory, exceptions.php. And we'll start with a simple example of just throwing an exception and seeing how this works at a basic level. First, we'll start like always with our open PHP tags. Next, we'll add an initial try block on line 2. Recall what the try block is. The try block says, okay, try this code, and I think it may throw an exception, and if it does, we're going to add a catch block to catch that exception. So let's add a new function call here in our try block. This function call is going to be process.cc, or process credit card. And we'll add a catch block after line 4 to catch all exceptions. To catch all exceptions, we simply say catch exception. And then we assign that exception to a variable. In this case, we'll assign it to the variable e. On line 5, we'll echo the exception message with echo e arrow get message. Let's add a few blank lines, and on line 8, we'll add our function process.cc. Now in this case, we want process.cc to take 2 parameters, a credit card number and a zip code to validate that credit card. So in this case, we'll pass in a parameter num. We'll set it equal as a default value of null, and we'll pass in a zip code, which will also have a default value equal to null. Next, add an if lock to throw a new instance of the exception class if number is null. So line 9 will read as if is underscore null, passing in num. Then we need to throw a new exception. This throw keyword is the mechanism by which PHP says, okay, here's an exception, and passes it up to the calling code, in this case into our try catch block. So we'll throw new exception, and we can pass in a string for the message. In this case, we'll pass in no CC number. So notice, all we do is create a new exception instance. We set a message. We can also add a code if we want to pass in an error code value, and we can pass in a previous exception as well. We then throw that new exception, and it will get passed into our try catch block. Outside of this if block, let's echo process. So if num is not null, we're just going to echo processed and assume that our credit card was processed at this point. Now save this, swap over to your terminal, and run the command php exceptions.php. And when we see that our exception is raised, which is exactly what we wanted. Notice how easy this was to build an exception to do some basic error handling and have our exception be caught by our calling code. Nesting exceptions is the process by which we can have one exception raised and a try catch block that catches the exception, then throws a new exception, nesting the other exception inside itself. This concept is used when you have multiple layers of code that might all raise exceptions. So let's modify our current exception code to throw a nested exception and see how this works. Let's open up our exceptions.php file in the exceptions folder. We'll add a new method after line 13 on line 15 to validate our inputs. So in this case, we're going to add a function validate, and it's going to take num and zip code. So what we are going to do here is, rather than validating our inputs in process.cc, we're going to validate them in a separate function. So we keep our functions small and simple. Let's take the code for lines 9 through 11, copy it, delete it from process.cc, and paste it in validate. Next, we'll add a try block in process.cc on line 9. So we're going to try to call validate, and if validate throws an exception, we're going to catch that exception, wrap it up in another exception, and then throw it back to our original try catch block at the top. Now here we want to call our validate method, so we're going to call validate, pass in our variables num and zip code. Next, we'll add a catch block on line 11, and we'll throw a new exception which will contain our previous exception on line 12. So the way this works, to throw a new exception that captures the previous exception, it's throw new exception pass in your message. In this case, we'll pass the message invalid inputs. An error code. In this case, we won't set an error code, so we'll just set it to null. And then the prior exception, which in this case is our variable e. This says to throw a new exception with the message of invalid inputs, a null error code, and a previous exception of e. Finally, we'll update our try-catch block in the root of our program to first echo a new line on line 6. After that, on line 7, we can get the previous exception, and then off of that previous exception instance, we can call our normal exception methods, which includes getMessage. So we will echo the variable e, arrow, getPrevious. So that gets the previous instance of our exception, and then arrow, getMessage. Now, we can save this, swap over to our terminal, and run our code with PHP exceptions, exceptions.php. And you'll see we have both of our exceptions raised. And we have our 2 exceptions displayed to the screen. First is our top level exception, the invalid inputs exception that process CC through. And second is the prior exception that validate through, the no CC number. It's super simple and easy to nest exceptions and use this to give yourself more detailed information as subfunctions may throw errors. Recall, we've discussed the PHP SPL in the past. The SPL includes in there a set of base exceptions that are commonly used throughout your application. It's a little too easy to just throw an exception for every little thing, but the truth of the matter, with a little bit of work, we can provide exceptions that are typed to the sort of failure cases we are typically dealing with. Logic exception is a base for most of the other exceptions we'll look at. Typically, you won't throw a logic exception directly. Instead, you either create a new exception or throw one of its subclasses. Logic exceptions are designed to reflect that there is a specific issue on this line of code, and here is where you can go to fix it. Runtime exception is the other base for the other exception classes. Again, you won't typically throw a direct runtime exception, but instead one of its subclasses. Now, this exception class, as you probably guessed, is designed to deal with errors that could have only been detected at runtime. So here are the rest of the exceptions that we'll cover in some quick detail. We'll look first at the logic exceptions and then the runtime exceptions. Bad function call exception is an exception to handle an invalid call to a function. Typically, this is used in conjunction with an isCallable function to say that a certain past function call is not actually callable. Bad method call exception is an extension of the bad function call, that instead of functions, it's on method calls. In most cases, you'll want to use this when using the magic call method to deal with methods that do not exist or are uncallable for some reason. Domain exception is used to handle a set of values that does not match whatever domain you are working with. Sticking with our example of processing a credit card, if someone calls that method with the context of a phone number, that's a domain mismatch. Invalid argument exception is probably one of the most commonly used exception classes. As you might guess, it handles the case where an argument to a method or function is an incorrect type. Length exception handles the case of a length being invalid, for instance the length of a file name being too long or too short. Out of range exception is similar to the length exception, except in this case you requested an illegal index, but this one typically occurs at compile time as opposed to runtime. An out of bounds exception is our first runtime exception, and it's the companion to an out of range exception, except instead this time we are dealing with an invalid index that can only be caught at runtime. Typically, this means with an array indexed by a string key as opposed to a numeric index. Overflow exception is when you add an element to a container that's already full. You get an overflow exception. Range exception is the runtime version of domain exception, where the issue with a value can only be detected at runtime. The exact opposite of an overflow exception is the underflow exception. In this case, rather than adding too many elements to a container, we try to remove an element from an already empty container. Unexpected value exception is raised when you have a function call that is dealing with a value that it wasn't supposed to deal with. Typically, this occurs when a function call foo has as one of its input another function called bar, and bar returns an invalid type for foo to fail on processing. Notice this is kind of a nested exception. It's designed to deal with these sorts of edge cases that we have when we're calling functions from other functions and they're returning stuff, and functions are doing weird stuff inside of each other. So that was a lot of exception classes. To keep it simple, the three you'll wind most up using is bad method call, invalid argument, and bad function call. That and any exceptions you write yourself. So let's use these to make our exceptions a little bit smarter. Let's swap over to our text editor and to the exceptions folder and open up exceptions.php. Let's modify line 21 to instead throw an invalid argument exception. To do this, we simply replace throw new exception with throw new invalid argument exception. And on line 14, we'll change the exception that we're throwing in process CC to instead be a bad function call exception. Now if we save all this and we run it using PHP exceptions.php, we see that we get the exact same input. Notice we're able to deal with these in the same way because we caught the generic type exception. We can change this to also echo the exact type of the exception that we're catching here. We can do this with echo get underscore class and then pass our exception class in. And we can copy this code and paste it as line 8. But here instead we need to pass in our previous exception, so we'll add get previous. If we save this, clear our terminal, and rerun the command, we'll see that it shows up as invalid inputs was the bad function call exception, and no CC number was our invalid argument exception. Keep in mind, in a lot of cases you won't throw these exception classes directly. Instead, you'll create your own subclass exceptions, and you'll throw those new exception classes to more precisely define exactly what happened with your code. I've mentioned before that one of the common tasks is creating your own exception classes to deal with a particular error case. Let's go ahead and do that now. We'll start with opening our exceptions.php file in our exceptions folder. Here we'll create a very targeted exception for dealing with an invalid CC number. On line 2, before our try catch block, we'll add a new class, invalid CC number exception, and it's going to extend the invalid argument exception. And now we can replace on line 24 our call to the invalid argument exception with invalid CC number exception. Now our custom exception is helpful, but not much at this point. So let's make it a little more useful. Instead of catching and throwing a new exception on line 19, let's instead simply just throw the already caught exception. So we'll replace line 19 with throw new bad function call exception with instead throw E. Now at this point, in our original try catch block, we're catching an exception E. We're getting its message, displaying the class name, echoing a new line. We're then getting the previous exception and then displaying the class for that previous exception. We no longer have a previous exception. So let's erase lines 12 and 11. And on line 7, instead of catching a generic exception, we can catch the specific exception, invalid CC number exception. So we can replace on line 7, catch exception, with invalid CC number exception. Now if we go over to our terminal and run this code with PHP exceptions.php, we see that we get our no CC number message displayed along with the class invalid CC number exception. So this was pretty useful. But is there a way to make this even more useful? One of the advantages of these custom exceptions is we don't actually need to set a message. We know with an invalid CC number exception exactly what the message is. So we can update the class construct method to pass a default message. So on line 3, add public function underscore construct that will take a message. In this case, we'll set the message equal to no CC number. We'll pass in a default error code, which will be equal to 0. And we'll pass in a previous exception, which in this case will be equal to null. We'll also call the parent function construct and pass in the message, the code, and the previous value. So this will be parent underscore construct, pass in message, code, and previous. and we need to return the result from our parent function construct. Now, on line 26, rather than passing in our message no CC number, we can actually remove this at this point. And if we go back over to our terminal and rerun the command, we see that we have our valid message displayed and the valid type displayed. Notice how easy this was. We built a custom exception that simply extended our normal exception class, and we built on it to say now we don't have to deal with passing a custom message. We can set default error codes, and our exception classes are now strictly typed to the type of exception and the type of error case we're dealing with. The finally block is a block that we can add onto our try-catch blocks to deal with any last cases, regardless of an exception being raised or not. Typically, you might want this type of thing where you are interacting with a file handler or making a connection to a socket, and you want to close the file handler or a socket connection regardless of anything else that happened. Let's see how this would work in our exceptions code. We'll open up exceptions.php in the exceptions folder. The finally block is a continuation of the catch statements. So on line 13, add finally. And on line 14, since we don't have anything to clean up, we'll just echo a new line and the word final. So we'll do echo, new line, and then echo the string final. And that's it for our final block. So let's see what happens when we raise an exception by saving and running this code as is. Recall, we're going to throw an exception, and in this case, our finally block should still run. So we want to swap over to our terminal and run the command php exceptions exceptions.php. And you'll see we get our no CC number displayed for our exception message, our invalid CC number exception class displayed, a new line, and the final string from our finally block. So this shows what happens when we have a finally block and we have an exception raised. Our finally block still runs. This allows us to do any cleanup, even if an exception occurred. Let's go back to our code editor and see what happens when our code actually passes and no exceptions are raised. For that to happen, we need to pass a value for the credit card number. So let's just pass the number 1. So in this case, on line 8, we'll update our try process CC to be try process CC and pass in the number 1. Save this, and we can go back over to our code, and we'll rerun the command php exceptions exceptions.php. And when we run this, notice we get the process line, our new line, and the final block. In this case, even though we did not raise an exception, we still had our finally block thrown. That's the entire goal of our finally block. Regardless of whether or not an exception was raised, our finally code always will run. This allows you to do any final cleanup or any other work that you need to do before you return to the normal flow of your program. That's it for exceptions. You should now be able to go out and build your own exceptions into your code as needed.